Welcome to lesson 60, and we have a two-part lesson today. This part is going to be talking about factorable trigonometric equations, and it's a way to factor our trigonometric functions in a way that we already understand using variables, but it's just easier and faster. So let me give you an illustration. We know how to factor something like this: x squared minus 1 equals 0. We recognize that is a perfect square, and we know how to factor a perfect square. We would just say x plus 1 times x minus 1 equal to 0, and then we would say our solutions, or our roots for x, would be a -1 and a +1. And then we would, that would be where we would stop, typically. If we had a equation that was set up like this, x squared minus x, or plus x, regardless, is equal to 0, we would know how to factor that as well. We would factor out x, and that would leave us with x plus 1 is equal to 0. So then we would set both of those equal to 0, and our possible solutions for x would be 0 and -1. So that is the way that we are going to solve some of these trigonometric functions. It's almost like a shortcut. Now that we understand how to do this, we can apply it to trigonometry. So let's look at those. I will say that for these types of problems, you are going to depend heavily on your unit circle. If you know all of your reference triangles, you don't have a unit circle, then you could always draw that up quickly. But your unit circle is so much faster and easier, you really need to keep that handy. So let's put that up here, and then we'll do 3 example problems. So here's our first example problem, and we have tan square theta minus 1 is equal to 0. Well, we recognize this as being a perfect square. If we treat all of this like an x square, we know exactly how to factor this. So what we would do is say the tan of theta plus 1 times the tan of theta minus 1 is going to be equal to 0. And then we would set both of these equal to 0, which means that our roots would be the tan of theta is going to be equal to a -1 and a +1. So this is where we would start using our unit circle. We would look for the tan of theta to be equal to -1 or +1 as we go one time around the unit circle, because our given is that theta lives between 0 and 360. So remember that the tan is the opposite over the adjacent, and this is the cosine. So this is the adjacent value, and this is sine, so this is the opposite value. So it's going to be the right number over the left number, and that's going to give us our tan result. So let's look for that. So I'm looking for either a -1 or a +1. So here I have square root of 2 over square root of 2. They're both positive. So theta is equal to a 45-degree angle. We'll continue around, and the next place I see that is a negative square root of 2, positive square root of 2, which would give us a -1. So that is at the 135-degree angle mark. So that is another possible solution for theta. So if I keep looking within that 360, I see a negative square root of 2, which is going to be a +1, and that's at 225 degrees. And then again, finally, I see negative square root of 2, and that's going to be -1, and that's at 315 degrees. And those are my 4 solutions, my 4 angle solutions for theta for this problem. So you can see it's not that difficult. It's really fairly simple once you understand to treat it just like you would be in factoring any other variable problem. We treat tan of theta like it's a variable until we solve it, when we get some possible roots for it. Then we go back to treating it like tan, and we calculate what -1 and +1 would be, or how we would get to it. So let's try another practice problem. So here we have the squared sine of theta minus the sine of theta is equal to 0. So we recognize that as like an x squared minus x. So we would factor it that way. We would say the sine of theta times the sine of theta minus 1 and set that equal to 0. And then that gives us the solutions or the roots that the sine of theta is either equal to 0 or positive 1. So for where the sine of theta would equal that, theta would be equal to, or the degree of angle would be equal to, let's look for 0. That's the sine is the second number, it's the number on the right, so that'd be 0 degrees. And if we continue to look for 0 as our second number, then 180 degrees. If I can actually write what I'm thinking today. A little dysgraphia going on there. So 0 and 180 degrees are the only places where the sine of theta is 0. So now we're going to look for the sine of theta being equal to 1. So the only place where that is equal to 1 is at 90, because here is 0 and here is negative 1. So 90 degrees is the only other angle solution for this equation. It's not super difficult. You just have to combine what you know about factoring with what we know about the unit circle and how to find our solutions there. So it's not so hard. You guys can do this. You guys are completely capable of this. Let's do one last problem in this part, and then we'll move on to some practice problems that you can solve on your own, and then we'll do the second part of lesson 60. So here we have cosine squared of theta is equal to 1. Well, it's a little bit of a trick problem. We know it has to be set equal to 0. So we'll subtract 1 from both sides, and what we really have here is a cosine squared of theta minus 1 is equal to 0. Now we have it in a form that is a perfect square, and we can factor that. So we say the cosine of theta plus 1 times the cosine of theta minus 1 is equal to 0. And then we would set both of those equal to 0, and that would tell us that the cosine of theta could be either a negative 1 or a positive 1. So that means the degree angle of theta is going to be equal to, we're going to look for the cosine where it's a positive 1 or a negative 1. So the cosine where it is a positive 1, we have a positive 1 here. So that is going to be 0 degrees where it's a positive 1. And that is the only place where I see that it is a positive 1. So let's look for negative 1. And the only place I see where the cosine is a negative 1 is 180. Because this is 0 here. So 0 and 180 are our only solutions for theta with this problem. So you can see how to do all of these by now. Don't let this throw you. It's just like a little trick question. You just have to rearrange it and get it set equal to 0. Make sure it's set equal to 0 first, and then you can evaluate what type of factoring needs to go on, whether it's pulling out one of the variables from both terms or whether it is a perfect square that has to be factored like this. All right, and that's all I have for 60A. So do the problems that follow, and then we'll do 60B.